the sustainable evaluation of the Blood and Tissues Bank of Catalonia using Verde tool. The Blood and Tissues Bank of Catalonia, BST, is a flexible, efficient and healthy container where the blood and tissue research and process is developed. The BST building has a mixed use, with 70% of its area used by the Blood and Tissue Bank and 30% used by municipal departments and facilities. The wide area for the blood treatment, hemovigilance and the cryogenic containers for the stem cells conservation are located in the basement. The analysis laboratories, research areas and offices are in the upper floors. The main challenge of this building is to ensure the possibility of adapting the space to the continuous change of program, which should need to modify workspaces, facilities and the access. This adaptability is also a sustainable quality because it can extend the building's life. The BST Center is conceived as a large box of white concrete made up of the facade and 4 interior nuclei that incorporate building service and access. These nuclei are like 4 backbones of the building. They support, contain and protect the building's vital networks such as accesses, services and communications. This layout will allow the building to adapt to any technological and organizational change that can be expected to occur. As in a human body, the nerves pass through the interior of the 4 big columns that arrange the building. In the Mediterranean region, the primary problem of office buildings is excess heat. In the BST, the thick facade, altogether with high levels of thermal insulation, act as an exterior shield against overheating. To reduce the emissions due to the use of the building, action has been taken on 3 key factors: reduction of the demand, improvement of the efficiency, and improvement of the management systems. The building has a thick wall in the facade with an increased thermal insulation. It acts as a shield against overheating. In addition, the holes represent less than 50% of the surface of the facade. The windows have low solar factor and high light transmittance window panes, as well as interior shutters with 95% reflection index that act as mirrors reflecting the heat transported to the sky, or reflecting the light into the interior spaces. These measures result in a reduction of the heat gains and the increase of natural light available throughout most of the floors, and protect the users against the acoustic contamination of the street. On the other hand, in order to avoid disturbing the environment, on the roof highly effective noise barriers in the louder installations core have been installed. In relation to on-site renewable energy production, solar thermal panels to supplement the heat production of DHW and photovoltaic panels for electricity production that revert to the network have been installed. A complete management system, BMS, has been designed for this building, for centralized control of all facilities and the improvement of the overall management and use of the building. At the same time, this system allows users thereof the ability to control their immediate environment through the use of room thermostats, as long as they respect the limits of temperatures and the air quality previously established. The building has an optimal behavior in terms of lighting comfort in workspaces and especially an efficient management of the natural light. The configuration of the plan allows most of the workspaces to be in contact with the facade, thus providing visual access to the exterior. The blinds are motorized and controlled by an automatic management system. Therefore, they can be adjusted to different external conditions, thus optimizing the intake of natural light and avoiding the discomfort due to glare. In individual offices, in addition to the global control system, there is an individual user control. Overall, the management system allows natural light to contribute to global lighting needs of the building with estimated energy savings around 75%. At the same time, the building's exterior lighting has been carefully designed to reduce light pollution. Firstly, the lamps used ensure that all light is emitted into their lower hemisphere. Secondly, a centralized management system has been installed, thus ensuring that more energy than necessary is not consumed. Outdoor lighting is turned on by a light-sensitive switch and is turned off automatically at an hour predetermined by the user, currently at around 7 p.m. The decision to install air conditioning equipment that allows free cooling permits natural cooling with cooler air from outside the building when available. Also, heat exchangers have been installed, allowing 100% heat recovery during renovation of air in the building. Occupancy and carbon dioxide sensors in key areas regulate the building's variable flow of heating, ventilation, and air conditioning (HVAC) systems. The building incorporates improvements in terms of health and comfort in general, and, in particular, in relation to requirements to prevent work-related illnesses such as lipatrophy. For this reason, the building incorporates a network for natural electromagnetic radiation dissipation in the foundations, conductive floors, and materials with a low volatile organic compounds (VOC) index. Additionally, 15 days prior to the occupation, and with the aim to remove any materials that could affect occupants' health, the building underwent a ventilation rate similar to that service. Regarding the waste generation, the building is connected through an existing pneumatic collection network to the treatment plant. A building with the characteristics of BST generates different types of medical waste, to which a special treatment is given according to the level of risk and the specific regulations. A waste management company is responsible for the collection, transport, and treatment of each fraction, always handling the corresponding certificates. With these certificates, an annual report is performed to reflect the results achieved by the waste management. Regarding water consumption, the building uses the most efficient fixtures and practices available on the market, such as low consumption fittings, aerators, and detectors. Additionally, the water used for toilets, irrigation, and air conditioning comes from the phreatic stratum. It covers the needs of water for these purposes and consequently reduces the total consumption of potable water of the building by around 50%. Despite that they are not taken into account in the environmental certification, the project has considered some additional decisions to improve environmental quality, such as geobiological terrain analysis to determine areas of intense electromagnetic radiation, and natural measures to counter them. Another aspect taken into account in the election of building materials has been their durability. The concrete used in the facades and in the structure is designed to last at least 50 years and needs very few maintenance operations. Interior finishing materials are reusable and easy to dismantle.